Good afternoon to all. Today we are designing two-stage RC coupled amplifier by using Multisim software. Already we know about Multisim software. Multisim developed by National Instrumentation Laboratory and it having inbuilt components. With the help of these components, we can design any kind of electronic circuit in an analog electronic circuit. First to see the designing of the two-stage RC coupled amplifier. After designing, we can simulate the circuit. After simulation, we can verify the output. That means AC analysis and frequency response. For designing two-stage RC coupled amplifier, first select the two transistors. Here this option represents the transistors. By clicking on this option, we can get the different kind of transistors: BJT, NPN, BJT, PNP, BJT, are there, Darlington, Pay, MOSFET, JFET, all transistors are there. For our experiment, required BJT NPN transistor, I am selecting BC 107 BP transistor. So again, BJT NPN transistors categorized into different models, but for based on our experiment, we select the type of transistor. Next, after selecting transistors, next we will go for resistors. Here starting option represents the power sources. Second one, basic components. In this basic component having the resistor, capacitor, inductors, all basic components are here. Click on resistor. Here different valued resistance are shown here. We can select the resistor which is applicable to our experiment. Place here, place here. Next, next click on right button. Here two options are there: 90-degree clockwise, 90-degree counterclockwise. So in which direction you want to rotate, you can rotate by selecting this option. Next, here also this resistor also. This one also. rotate clockwise. Next, change the values. R1 value is 100 kilo ohms, R2 value is 10 kilo ohm. So double click on this component, then immediately open the window like this. Here value option is there. In the option, we can change the values. Which value you want, we can change. Next, select the capacitors. Same. Here second option represents the basic parameters. In this basic components having the resistor, capacitor, inductors and all. Click on capacitor, it will show the different valued resistors. Select which capacitor you want. Same. Click on this. Click on right. Rotate 90-degree clockwise. Same. Rotate 90-degree clockwise. This one. So rotate. Here this one no need to rotate. Next to select the power sources. First to select the first option represents the different power sources. Here having different power sources, AC power sources, DC power sources, control voltage source, control current source, all options are there. Click on power source. Select the DC VCC power supply and keep it on top. Select the ground, keep it on bottom. Next to go to signal voltage source, select the AC voltage source, keep it here. All component selection over. Next to give the connection. When cursor comes to edges of component, automatically it will indicate the wire. Give the connections. Then after giving connections, double click on DC power supply VCC, change the value from 5 to 12 volts, and double click on AC voltage source, change the value from 1 volt to 1 millivolt, and frequency is 1 kilohertz. Next, select the CRO. Here, left side having so many options. These all are represents the millimeter, function generator, watt meter, oscilloscope, 2-channel oscilloscope, 4-channel oscilloscopes. All are here. Select the 2-channel oscilloscope. Channel A connected to output. Channel B connected at input port. Here negative terminals of both channels connected to ground. After giving connections, then start the simulation. Double click on oscilloscope. Then observe the output waveforms. Here both are connected with a red color. So both waveforms are red colored. So if you want to identify the which one is a input, which one is a output waveform, so better change the color of the one channel. Double click on oscilloscope, click on simulation. Here channel A time is common for channel A and channel B. Here voltage scale only different. This is the output waveform. This is the input waveform. Here blue colored waveform is the input waveform. It is in 1 millivolt. Red color waveform is the output waveform, and it is a 1 volt signal. Here we applied 1 millivolt signal as an input, but we got 1 volt signal as a output. Here 1 millivolt amplified into 1 volt. Stop the simulation. Close the waveform window. Next click on here. Click on show net name. Select OK. Net number is 8. For AC analysis, go to simulate. Go to analysis. Here, select the AC analysis. Here start frequency decided 1 hertz, 1 hertz. Here vertical scale, horizontal scale. Here vertical scale having the values, frequency values. Vertical scale having the decibels. Click on OK. Here all variables are here, but we need V8. V8 only the output node. Select the V8 and simulate. Select and add. After adding variable, then simulate. It is the magnitude response and it is the phase response of the two-stage RC coupled amplifier. So keep on select the bars. Okay, now we can, with the help of these cursors, we can analyze the values of the magnitude spectrum and phase spectrum. Next, to close the graph. Next, go to simulate, go to analysis, select transient analysis. Close it. Go to simulate, select post processor. Here variables, functions are there, variables are there. First select the variables. Decibel of, we need decibel of, select decibel of. Next here, select the A, copy function. Decibel of voltage, add. Next coming to the graph, first add the post process phase one. Next add the diagram one. Here expression variable, select the expression variable and add into here. Next calculate the frequency response. Select the cursors. Here maximum voltage is here, horizontal axis, vertical axis is there. Horizontal axis represents the frequency values, vertical axis voltage values in decibels. X-axis and Y-axis. Y2 is there. Here 54.509 is the maximum voltage. So minus 3, maximum AB max minus 3 represents the lower cutoff frequency and higher cutoff frequency values. 54.509, 51.509. Same cursor one also keep it on 51.509. Here cursor 2 represents the maximum frequency FH. Cursor 1 represents the lower cutoff frequency FH. So by doing F2 minus F1, we can get the bandwidth. It is the two-stage RC coupled amplifier. Thank you.